Looking at this Trane furnace here, we had a 3-flash pressure switch fault. When you see this water over here like that, rust, that's never good. But this furnace is, when we pulled the inducer off, we saw rust right there. So this transition piece right here is cracked, which is a pretty typical thing for this furnace. They also put, you see all the rust by the screws here. That secondary was about 2006. They put the wrong screws in the factory and it cracked all the secondaries. But this one was manufactured in 04, so that may or may not be happening on this one. I'm going to pull this off. This piece obviously is cracked right there. You can see it. So we're going to change that, and that's hopefully why we were getting our 3-flash on this one. It's a TUX. We got the new transition piece mounted on there. It didn't appear there was any problems inside there with the heat exchanger. So we just got these 4 screws right here and that one there to put this plate back on. And then we'll mount the inducer to that, which is these 3 screws right here. And that's it. All this here, we took this off so we could get our nut driver in for that bottom screw on the inducer. So that's what that looks like with the plate mounted. And now we just run a bead of caulk around there and put our inducer on there with those 3 screws. So that little thing there will clean up and put a bead of caulk in it, and it'll line up with that circle. And you just gotta slip that over that, and your 3 mounting screws, and then hook up the drain to the bottom of the inducer there. So the most common 3-flash pressure switch fault on this furnace would be just leaves sucked into the intake, and you can always just try and pull that out and see if anything's laying there, hornet's nest, whatever. And if you pull that off and it fires, chances are there is something in there, so there could be a bird's nest in there. The best way to attack that, if you can, get a shop vac in here, tape it on there with duct tape and blow it out. The other thing was plug drain. That's not very typical with this trap to plug up. That's more of a carrier situation. But first thing I did when I got here was clean that trap. And then always look for rust underneath this inducer. And that's a telltale sign that that part we replaced today here on this one was cracked. There's rust beneath the inducer. So make sure you get your drains hooked back on. I did blow out all the drains that go to the trap. There's one there and this one here. They come down and tie into the top of the trap there. And of course I blew that out too, the main drain. But usually you'll have an inducer that's gurgly if the drain's plugged up. Again, not very common on this furnace. So that little part we did would be the most probable. Or frosted over intake if it's really cold out and you got a screen or not enough separation or concentric vent kit out there, that'll recirculate and frost over when it's really cold. That's about it for this furnace. Alright, I started this job on a Sunday, and even after replacing that transition piece, we were intermittently faulting out. I left it running when I left here yesterday. When I just got back from the parts store, just put a new pressure switch in, so obviously on a pressure switch fault code you could possibly have a bad pressure switch. I was just out looking at the vents outside. The homeowner said he was trying to vacuum the pipes out. I don't know if he was doing it from in here or out there, but my last step is going to be, I'm going to hack off this intake pipe here and hook up my vacuum and blow it outwards just in case we got a bird's nest in there. that got jarred and is now halfway blocking the pipe. So I'll show you that here in a minute. Okay, I got my manometer teed in. This switch is supposed to be closed at 1.4. It says right on the switch, hopefully on whatever you're working on. See it there, 1.4 inches. And we're at 1.53. Furnace is faulted out with the brand new pressure switch. Not looking good. Let's see what happens when we pull off this pipe. Didn't really change anything there. And that's really close to what we're supposed to be closing the switch at. That switch should be closed. Hard to say what's going on here. I mean, with that pipe off, that kind of rules out the pipe being the issue. There goes the inducer down. That was just so close. I'm going to get my meter out and see if that switch is closed. I just tried to run this fish tape down the exhaust from the outside. There's two elbows. I got past the first elbow but couldn't get past the second, so I'm guessing maybe something's in there, but this fish tape ain't that strong either, so I'm gonna cut it open. EJ's gonna bring me the camera. If I don't see anything right where I cut it open, I'll have to stick the camera in there and take a peek. So here's our vent configuration. When they built this deck, thankfully they just didn't leave it below under the deck. They did the right thing, brought it up and threw a box up there. The intake we know is not an issue. That's at 45. So that fish tape, I got past that first elbow and I couldn't get it past this second one. So I'm going to cut it open there and see if I can see anything. Okay, so after all this, I just cut this pipe open. I can barely see, there's like some toy sticking right here. So I shoved whatever that was down a little bit with my fish tape. I hope there's not too many toys in there, but I don't know if you can see that or not, but there's something in there. I'm gonna have to cut this open the rest of the way or see if I got something to grab it out of there with. We got Eeyore and what was that other one? Tigger. Plugging up the work. These guys, troublemakers. Here we are back at the problem job from Sunday, replacing the furnace. This boiler is 80,000 BTUs and it's taking care of the basement. So we measured up the upper two floors and came up with like a 67,000, something like that, heat loss for the upper two floors. So we're putting an 80 in here, taking out a 120 and putting an 80. They got two thermostats, two zones. I would imagine this heat exchanger is compromised. We still don't know why the furnace is intermittently not running on a 3 flash, but it was warm and running when we got here this morning. So it's a very odd situation. Anyway, we're getting rid of this old Honeywell single stage panel, putting in our 2-stage zone panel. Here's that furnace. It's a wonder it worked at all. I mean, that crack is turned into more of a hole. This one's cracked. That one's cracked. So that one's bowed in. It's just almost melted through. So we got one cracked on both sides. This one's cracked on one side. This one's melted here and just almost got a hole in it there. This is why zoning is not good if you don't set it up right with a two-stage zone panel or the proper bypass, because, and not only that, the furnace is 30% bigger than it, 50% bigger than it needed to be. I'm putting an 80 in here and we're taking out this 120, so it's unbelievable. Never seen a furnace like this get destroyed so badly, and it's just based on improper installation. It's nothing to do with the furnace, and usually that's what it is. It's never the furnace, it's the installation. Okay, we're just getting our rails in here. The door fell right off of here. Lucky nobody got cut. Corey was pushing up on the coil and it fell right out of the S-lip, and these aren't snap lock seams, so it fell right out and the coil came forward, and it was really dangerous. But the coil's clean. Oh yeah, this thing, unbelievable. It's almost wore through right there. Alright, we are getting set up here. We're going to get this drain tee mounted on the intake right here before we shove it up against that wall. We got our furnace drain in, trying to get everything put together as much as we can before we stick it up in there. I don't know if I should screw this on now or wait till we get it up in there.
Screw it on now.
I think we'll wait. You want to screw it on now?
I think we should.
Okay, if you say so. We won't be able to get past that. We won't be able to get past this though.
Well, who made this in the shop?
Right here. This will be in our way, so we're gonna wait just because this is hanging down.
Yeah.
I suppose we could push it up though.
You
always got to think ahead though. We can screw it down. See, if we put screws in here, then when you come to change this furnace in 30 years, what do we got here? That's gonna burn off. Check that out.
Look at that mint plum.
Yeah, nice work, Corey. Real nice. Show this video to Dan. That's beautiful. Nice job. Okay. So the one thing I could have done early on in this service call was pull this burner door, and we could have shined a light right in where our burner's going. We could have seen these cracks. Probably would have saved me 4 hours of nightmare and driving around for parts I didn't need. So if we just shine our, okay, so in order to do that, we would have to pull that top thing. So pull those 3 screws and grab that thing out of there. All right, we got that burner bracket out of there, and you still, let's see, it's so hard to see right now. Still can't see, so we're gonna pull the burners out of there. This would be a lot It's a lot of work to pull these burners out and get them back in there, but if you suspect that the furnace was oversized and there's not enough airflow, then I would highly recommend pulling these burners and looking in there. Okay, so if we look up here, here's our worst one right here on the third one over. Okay, now, I don't know if you guys can see it, but I can definitely see that crack in there at this point. But the only way you're going to do that is to pull the manifold down, pull the burners out, and here, shine that light up in there. See if we can see the crack. Shine it in the light. Which one is it? Yeah, put it right up against that. Still can't see the light in there. Let me see with the flash off. Oh, there. Now you can see. Move that flashlight back and forth. Yeah. So you can see that crack in there with Corey moving that light around.
Right there.
You see it? So it's hard to see. Yeah, let me see that.
There it is. That's the crack. Yeah.
You see? Oh, you can see it.
Yeah.
Yeah. Yeah, there it is. So it's hard to see on camera, but with the light shining through there, you can see that. So if you pull all that apart, if you got that pressure switch fault, I'll tell you what, next time before I do all that, if I think the airflow was an issue or the furnace was oversized, I'm definitely pulling those burners before I head down this 4 or 5 hour trail that I was on this one. Even though we found toys in the vent and we found a cracked transition piece behind the inducer, in the end we had an oversized furnace that was lacking airflow, and the zoning system with no bypass and all that just made things worse. So the other thing you could do is pull that limit switch. Certain furnaces you can pull that and you can see the primary where it cracks. That carrier 80% is the one that you can see through there. I don't believe you'd get your eyes on this crack from pulling the limit switch, which is that thing right there sticking through, which is right here down just above the gas valve. Usually all your furnaces are going to have primary limits sticking through between two bays of heat exchangers there to protect it if the blower motor fails or the board is not turning the blower on or somebody neglects their air filter. So if you had a camera, you could snake a camera through that limit. The other thing you could do is cut a hole in the back of the furnace if you can get to it, which would be my first probably preferred situation. You know, if you cut a hole right there up high, you could probably see that crack. So that's everything you need to know about a pressure switch fault right there. To wrap, I think I do. We're just checking out the air exchanger here.